Hello everyone, welcome to another technical talk. This talk is part of an NSF NHERI workshop and mentoring program, and the topic of today's technical talk is overview of rapid reconnaissance efforts and barrier island breach evolution in Florida after Hurricanes Helene and Milton. Uh, so we are pleased to have Alexandra Schueller, PhD. I believe at the moment they did this research that is really interesting. She was a postdoc at University of Delaware under supervision of Jack, and also she was a guest investigator at Woods Hole. And now she's a professor at Hochschule Koblenz, if I'm not wrong. And before we proceed, so as I mentioned, this talk is one of the missions of workshop and mentoring program. NSF NHERI Graduate Student Council provide you with many opportunities from the conferences, the technical talks like this, and workshops that you can learn like many things from them, like the softwares, open seas, stuff like that. And beyond that, you can build a community, connect with many people from different fields, from coastal engineering to wind engineering, geotechnical, earthquake, and anything related to natural hazard. And also, you have the opportunity to attend the conferences, use our fundings, resources, and many great other stuff. So you can join the Graduate Student Council. It's completely free. You can use this link, barcode, and you can join our community and use our resources. I think I already introduced Alexandra, but again, Alexandra Schueller, Dr. Alexandra Schueller. She is a PhD, and now she's a professor at Koblenz University of Applied Sciences, or Hochschule of Koblenz. And she was a postdoc, research associate at University of Delaware, and guest investigator at one of the best institute of oceanography in world, WHOI. And she's going to talk about their campaign, the campaign that they had with that is I believe is run by one of NHERI facilities, Rapid, on the barrier breach evolution. That's a very interesting topic. You can contact Alexandra using the email, and if you have any question, of course, you can ask her after this, after her presentation. But even if you wanted to reach out and ask more questions or know about the research and the career path, you can use this email to contact her. So I stop here, and I want Alexandra to share her presentation, and you can learn many things from her today. Thank you.
Yeah, thank you very much. Then let me quickly share my screen. So I hope you can see my slides, and if not, please give me a short feedback. So hello everyone, and greetings from Germany. Thank you very much for the kind invitation. And welcome to my presentation with the title Overview of Rapid Reconnaissance Efforts and Barrier Island Breach Evolution in Florida after Hurricanes Helene and Milton. My name is Alexandra, and today I will talk you through our reconnaissance efforts in Florida and provide an overview of the data that we made available for you on DesignSafe. And during my time as a postdoctoral researcher at the University of Delaware, I was involved in those 3 post-storm field surveys and led the most recent one in June together with Nina Stark. I've structured the talk for you into 4 different parts. So first, I will give you a short introduction about the EERs, especially about NHERI and GEAR and the idea behind the survey. Then I will provide a timeline and summary of the 3 reconnaissance missions and the corresponding data products that you could use. And after that, I will talk about some first results and our NSF EAGER project. And at the end, I will quickly talk about our international reconnaissance workshop and young professionals activities during the next international conference on coastal engineering happening in Galveston, Texas. So, as you all know, when a hurricane makes landfall, it impacts both the ocean and the land. And to truly understand how a storm affects a coastal region, we need to capture both sides of the boundary. So the water and the land and everything in between, also this shallow area in between. And that's why our team focused on building a seamless picture using methods that work together across the air, the water, the land surface, and the subsurface. And each method fills a gap, and together they create a full and connected story. And I want to show you how this data set brings together this seamless picture across multiple disciplines and time frames. And capturing a data set this diverse and time sensitive requires a large and multidisciplinary team. So let me introduce the team behind it. So here you can see all the people who were involved in these missions. And the very special thank you goes to our leads, Nina Stark from University of Florida and Mike Gardner from UC Davis. They led missions 1 and 2 and handled most of the organization. They initiated the entire effort, and that was a lot of work, and they did an amazing job. And without their leadership, none of this here would have been possible. So I collect the 3rd data collection together with Nina Stark in June. But as you can see from this long list of names, I'm only one small part of a very large team. And that is why it's an honor to present this work today on behalf of everyone involved. And here you can see the list of all the names, and I'm really happy that one of our team members, Michael Bennett, is also here today. So we are grateful for the support of all our team members from universities, agencies, and partner organizations. And I also want to thank Britt Robenheimer from NHERI and David Frost from GEAR for their guidance and support across all missions, and their experience and coordination were essential, bringing the 2 groups together. So because this is a NHERI workshop, I would also like to talk about the NHERI institutions. So as you all know, we have those different EERs that focus on reconnaissance efforts. And there, because we had here a multidisciplinary survey, we had from the EERs GEAR involved and NHERI. And additionally, we used the DesignSafe cyber infrastructure and worked together with the RAPID facility from the University of Washington. And because some of you might be interested in joining one of the EERs maybe in the future, I would like to introduce GEAR and NHERI really quick. So first, I would like to start with the introduction to GEAR, and I want to thank David Frost, the lead of GEAR, for providing the slides and the information. So the mission of GEAR is to document geotechnical impacts of extreme events, to advance adoption of innovative reconnaissance technologies, and to train early career researchers in safe ethical practices. What is very important to you, isn't it? So they coordinate effective geo-reconnaissance teams, and they collaborate with the other ERs, with the NHERI infrastructure and related response groups. They standardize measurement and reporting protocols, and they provide timely and accurate post-event data reports. So the focus of GEAR is to collect perishable data. They create record of what happened at different scales. They focus on facts, not on opinions, and serve as a foundation for future research studies, as you can see later, for instance, with our upcoming EGA now. Then it impacts future policy and standard development, and GEAR enhances future geotechnical practice and increases resilience of infrastructure. And documenting no damage is just as important as documenting damage. So here you can see a screenshot of the GEAR website, and you can see they had a lot of missions all over the world. So if you are interested and are part or working in the geotechnical field, I can highly recommend to visit the website and to find out more about GEAR and their work. Now I would like to briefly introduce NHERE, the NHERI facility that I'm part of. So NHERE focuses on extreme event reconnaissance in coastal, nearshore, and estuarine environments, and it supports researchers by providing tools, coordination, and clear methods for fieldwork. With fast post-storm data collection, NHERE helps improve models, risk assessment, and coastal planning. And the chart here on the left side shows that NHERE brings together people from many disciplines so we can understand the full picture of a storm. And socioeconomic choices also matter. In this example here in the figure, a roadway was damaged, and the future safety of the beach and the community depends on whether the road is rebuilt in the same place or maybe removed. To understand the situations like this, we need to look at all connected parts of the coast: the water, the land, and the vegetation, the groundwater, the buildings, and of course the people. And the figure shows how these parts influence each other and how they are connected. So the system is changed by the storm and post-storm management response, and this makes the data highly perishable. And there's a need for data before, during, and during the storm, as well as afterwards. So the mission of NHERE is to obtain perishable data before, during, and after extreme coastal events, to coordinate interdisciplinary teams studying nearshore systems, and to entrain a broad community of nearshore researchers. So building on this NHERE and GEAR framework, and I can highly recommend that you have a look at the home pages. Now I would like to move on to the two storms we focus on today, Hurricanes Helene and Milton. And together, these storms caused more than $200 billion in damage. Yeah. So Hurricane Helene's storm surge destroyed about 70% of homes in Horseshoe Beach and about 25% in Cedar Key. Hurricane Milton caused another $34 billion in damage, mostly in Florida. Helene made landfall on September 26th in 2024 in the Big Bend region near Perry, and Milton made landfall on October 9th near Siesta Key as a Category 3 storm. Now I would like to tell you a little bit more about the mission itself. So our fieldwork covered 3 main locations. First, Cedar Key and Horseshoe Beach, both were affected by Hurricane Helene. And then as a third location, we had the area around Sarasota that was mostly affected by Hurricane Milton. And there we had 2 breaches in this region, Midnight Pass near Sarasota and Milton Pass near Englewood. So, as I said, we worked around the 2 hurricanes. So we had Helene in late September and Milton just 2 weeks later in early October. And because we had a lot of efforts going on, I would like to highlight this on the timeline. So we had 3 big data collections marked in red. 1 mid of October for post-Helene, 2 post-Milton surveys near Sarasota area. Additionally, 1 mid of November 2024 and 1 mid of June 2025. Additionally, we had 2 pre-hurricane surveys and sensor deployments. 1 before Helene in Cedar Key and Horseshoe Beach, and 1 before Milton, also in Cedar Key and Horseshoe Beach. So we were able to capture pre, during, and post-storm data for both events, and that's extremely unusual. So a team was formed on September 23rd, and the decision was made that the team will be led by Nina Stark. And then there were a lot of additional discussions going on, for instance, within the NHERI teams and colleagues on Design Safe Slack channel, for instance. The Rapid Facility came on board and provided staff and wave gauges, drone slider, and survey equipment. And all this, happened in coordination, happened in 2 days. Yeah, so the team went out on September 25th and to collect first data with the goal to understand effects of nature-based infrastructure interactions amongst geotechnical and coastal ocean and atmospheric processes. And the data collection here happened just 1 day before Helene made landfall. So just that you understand, so everyone went out of this area and the team with researchers went into that area to deploy sensors and to make this to create this very important data set. So they collected LiDAR, they had remote sensing with drones, then they brought out hydraulic sensors. And in detail, they brought out 70 water level sensors and wave gauges, 4 pore pressure sensors, 1 ADCP. They had LiDAR measurements and aerial imagery that was done by the Rapid Facility. And the sensor recovery and an initial site reconnaissance was conducted by a small team on September 29th, so within 72 hours of passing of Hurricane Helene. So the plan was to do a multidisciplinary post-storm data collection beginning of October. But then, surprise, Milton crushed our plans, made landfall 2 weeks after Helene. And so the team with Nina Stark decided to do another pre-deployment in the Cedar Key, Horseshoe Beach area. And that happened from October 6th to 8th. So they redeployed water level sensors and wave gauges for Milton. Unfortunately, Milton went another way than expected, but yeah. So finally, we were able to do the big data collection in Cedar Key. Milton left Florida and the team arrived, including me. So fortunately, Milton had no influence on the Cedar Key area and made landfall more in South Florida. So we collected LiDAR, we had remote sensing, hydraulic sensors, a big hydraulic survey and a geotechnical survey. And the data includes hydraulic information on storm surge, waves and currents, topographic and bathymetric data sets, terrestrial and seabed mapping, and geotechnical site characterization, including in situ testing, sediment sampling, and seismic testing. To provide an overview of the instruments and methods we used, and that you get an understanding, that you can see it, I included a selection of images for you. So for instance, we had erodibility testing using a jet conducted by the NC State University. Then we had seismic subsurface characterization, aerial LiDAR, geotechnical subsurface characterization using a DCP, then terrestrial multispec imaging, detailed sediment and subsoil characterization, hydrographic and hydraulic mapping, and last but not least, shallow bathymetry using the sea boat from the Rapid Facility. After the data collection in Cedar Key and Horseshoe Beach, our team split up and some of us headed further south to do a pre-survey of the Milton area. And based on that pre-survey, we decided to go back in mid-November to collect more data around 2 breaches near Sarasota that are called Midnight Pass and Milton Pass. And Midnight Pass reopened as a new breach during Hurricane Helene. But it was opened before around and was closed around in the 80s and was cut open again because of Hurricane Helene. And during Hurricane Milton, a new breach called Milton Pass formed further south, creating a second opening in the barrier system. So one reopened breach, one completely new open breach. So we collected again all those things listed that I listed before. And additionally, we had another survey at Midnight Pass and Milton Pass in June 2025 that I initiated and then co-led together with Nina Stark to see how those breaches have developed 6 months after the storm. So, and now I would like to show a video about our survey that you can see those locations, the people involved, and also the instruments and methods involved.
2 hurricanes, 2 breaches, 42 researchers, 2 survey days, 6 months after landfall, 4 boats, 2 jet skis, 1 drone, 1 airplane, 20 plus instruments, 6 universities, 2 U.S. agencies, 2 consulting firms, 100% teamwork, 1 shared mission, coastal resilience. Next steps, data processing, analysis, interpretation. Stay tuned.
Yeah, as you can see, a lot of people were involved in this data collection. It was a multi-institutional and multidisciplinary effort, and we collected data at both breaches. So this time in June, we were not under pressure right after a hurricane. So we had time to rethink our methods and try new things to get that seamless picture that I was talking about at the beginning of the presentation. And here you can see all the methods we used in June. So for topography and bathymetry, we used the River Pro, we had echo sounders, jet skis, RTK, an RTK survey, terrestrial LiDAR, drone and airplane imagery, and satellite imagery. For sediment and subsurface, we used GPR and DCP, Aurora, Viper Sand Auger, Blue Drop, and Field Flume from Nina Stark. And additionally, we had some monitoring from ERDEC. So ERDEC deployed field cameras. And regarding the hydrodynamics, we had stationary ADCPs that we deployed in Midnight Pass, and also the River Pro that surveyed Midnight Pass and Milton Pass. So, and now after collecting all these data, the question is, how do these pieces and the ton of data fit together, and what story do they tell us? So, and with this, I would like to tell you a little bit more about our results. So I can tell you that cleaning all the data, sorting all the data, that was a lot of work. You can see we had so many different data collections. We are all doing this in parallel to our normal work because we are really passionate about that topic. But yeah, analyzing the data and really bringing it together takes time. When I'm new in the area, what do I do first? Yeah, of course, I want to get a big picture. So the first thing is using remote sensing to get a first information about our sites and what is going on. So let's have a look. So this is an image collected with a Ringtra Gen 2 drone by Reconnaissance from University of Central Florida. And here you can get an information about the bathymetry, a little bit about the currents going on. And you can see as well a lot of boats, and we had more boats actually during our data collection. So we had a lot of boat traffic and also people swimming. And for me, like leading this time, the first time, like such a big data collection, that was really challenging. Yeah. So you needed to take care that the boats are not in the same spot where you want to collect data, for instance, with the ADCP or the anchors, that they don't destroy our sensors that we deployed on the ground, on the seafloor, all those things that I never thought about before. So this figure here was created by Sam Holberg. He's an amazing graduate student at NC State. And this year is part of his poster that he presented during RCM conference in Barcelona. It shows the shoreline change happening at Midnight Pass from October 2024 to June 2025. It just shows the shorelines in different colors, with blue for October, and the brighter the color, the later the data. So green is summer, when we had our second data collection. So in general, the dune eroded at Midnight Pass by Hurricane Helene and breached during Hurricane Milton. And the inlet is in a relatively fixed location, fluctuating in width between 19 to 45 meters. And a sediment plume happened or formed after Milton, and then eroded again away. Additionally, a split formed and directly eroded again in February 2025. So now let's talk about Milton Pass. And here again, a nice imagery or nice image from Ray from University of Central Florida, and you can see two things. You can get information about the bathymetry, the vegetation, but also we have less boat traffic, and that made a huge difference for our data collection. I never thought about that before. But we had huge currents going on in between the breach, for instance, and then you need to be really careful when you want to enter the ocean side and want to collect data there. So all things that you need to think about. So here again, for Milton Pass, a nice figure that Sam from NC State created. It shows again the shoreline change for Milton Pass. Purple color shows again the October data. And then the brighter the color gets, the earlier or later the data is. So green is actually then for our summer data collection in June. And Milton Pass breached during Hurricane Milton. And we can see a gradual shift around approximately 90 meters south, with the north barrier moving faster than the south barrier, and a marsh bank erosion occurring along the lagoon or intercoastal channel. And now I would like to talk a little bit about our geotechnical survey. So we also collected geotechnical data at the breaches. And here's a nice picture created by Stephen Aduse from University of Florida. He's a graduate student with Nina Stark. And last time we felt that an important puzzle piece or that important puzzle pieces were missing to fully understand the geotechnical data when we had a look at our November data collection. So we are very glad that experts from USGS, ERDC, and University of Central Florida joined us, and their knowledge added a lot of value to our work. So this time we carried out a much more detailed survey. And we used three main tools: DCP tests, Auger course from USGS, and GPR from ERDC and UCF. And together, these give us a picture of the soil strength and the layers below the surface. So the DCP tests that I collected also in June together with Michael Bennett were done, as I said, in November and then again in June 2025. Along transects across the breach and the beach and the back barrier. And they show how the soil resistance changes with depth. And all locations were measured additionally with RTK, so we can link them to our topography and bathymetry data. But DCP and RTK was not enough to understand the picture for our November 24 survey. So in June, we also took Auger course next to some DCP points, and these cores help us check what the layers actually look like regarding grain size, shells, and other material. And the GPR lines were run along the same transects. So we had 200 and 500 GPR instruments. So the low frequency GPR shows deeper structures, and the high frequency GPR shows the shallow layers in more detail. And so we were lucky that we had two GPRs, yeah, so from ERDC and UCF. And so we were able to just run both instruments and to see which one is more helpful for us for future reconnaissance efforts. And so by combining all three methods, we can see how the subsurface structure changes across the breach. And this helps us understand how the barrier was built, how it failed, and how it may change in the future, something we cannot see from surface data alone. So here you can see what our land survey team is working on right now. This figure will appear in our upcoming Geostrata article soon. I think will be published in April, I guess, March or April. And we are combining all land-based methods and are also working on a tech note and a journal paper. Our GPR surveys across the washover fan show three main layers: an older estuarine unit, the washover fan with landward dipping beds, and the beach unit with mixed bedding directions. And both GPR systems, here you can see the 200 Hertz on the upper side, and then below the 500 megahertz GPR show similar structures. And when we compare the GPR lines with the DCP resistance in the lower picture, they match really well. So the stiffest layer is at the base of the washover fan, and the softest layers are at the top of the beach. And by combining GPR and DCP, we get a much clearer picture of the subsurface. So GPR shows the structure and DCP shows the strength, and together they help us understand how the barrier changed after the storm. And now I would like to talk a little bit about results from the NC State team, Celso Castro-Bolinaga and Sam Holberg, about the results from the hydraulic surveys we conducted in November and June. So regarding our water surveys, we had in general bathymetric and hydraulic measurements. So we used acoustic Doppler current profiler, an ADCP called RiverPro from NC State. And for the bathymetry, we had also two jet skis with collecting single beam bathymetry with wave runners. And now I would like to show you some preliminary results for our RiverPro. So those figures are again created by Sam Holberg from NC State, and it's part of his poster that he presented during the RCM conference in Barcelona. So on the top, you can see the bathymetry, and then below the velocities for November 2024 and for June 2025 on the right side. So in November, the deepest point was about 4.4 meters, located on the north side of the inlet channel. And the inlet was still fairly narrow at this time and only about 22 meters wide. And in June 2025, the deepest point had shifted to the south side at about 4.3 meters. And the inlet had widened significantly, reaching about 39 meters. So, and as well, we have here the velocities, and with that, you can get information about the currents, and it's very important when you want to add that into a numerical model. So for Milton Pass in November 2024, here again, we can see that the inlet was about 3.6 meters deep, and it was around 140 meters wide. So completely different in comparison to Midnight Pass. And the flood channel was wide, about 60 meters and roughly 2.5 meters deep. In June 2025, the inlet became narrow, about 105 meters wide, and had shifted about 60 meters since the survey in November. And a clear flood tidal delta developed in the South Lagoon. And the flood channel became narrower but slightly deeper, about 2.9 meters. And what I want to highlight here is that channel width of 140 meters. Just that you understand. So those both breaches were very remote locations. So we needed to shuttle in those 42 researchers in with boats. So that took a long time to shuttle them from the boat ramp to on site. And then when they collected data on one side of the breach, they needed to move to the other side of the breach. Yeah, and with the equipment. So we needed 2 boat shuttles that were all the time circling around. We had text messages sending us that the boat can shuttle different groups around. So as you can see, there was a lot of coordination needed for those surveys. So with this, I will end the presentation about the results, and I hope this gives you a sense of the many things we are looking at, and each person on the team is working on one important puzzle piece right now. As I said, the data cleaning and processing took a long time. Now we are on the stage of analyzing the data. So everyone is doing their homework and everyone has one puzzle piece, I would say. And now we try to bring the researchers again together to bring the data together and the results and to start the discussions and to bring it into numerical models, for instance. So we are still in the middle of the analysis, and as I said, those are still preliminary results. And now the goal is to put everything together to see the full picture of the puzzle. So overall, our field measurements generated a unique data set that will enable advances of fundamental knowledge and predictive understanding to improve coastal protection and impact mitigation. And team members now started to bring the information into numerical models. So our data set is available on DesignSafe if you are interested, and it is organized by site. So we have 4 primary sites and others. It is sorted by instruments and data collection methods and organized based on data collection phase with respect to the 2 hurricanes. And you can see a lot of people contributed to the data set. It includes the stage 1 and stage 2 data. So it's not, so we are still working on publishing the data for the June data collection. So when you go on Design Safe and then click on our project, I would like to highlight here one thing. And this is, we have here a little icon. And when you click on this icon, you get to the HasMapper app. And this is a really cool feature included in Design Safe, but you need to know the trick to click on this little icon there. So when you zoom in, you can see the data that the RAPID facility here collected for you. And I think this is especially interesting for all of you who are working, for instance, in structural engineering, to get an understanding of what is going on here, for instance, in Horseshoe Beach directly after the hurricane. So additionally to the Design Safe dataset, we are writing a report, NHERI report led by Nina Stark and Mike Gardner. And the report will be published soon. The team is still working on including additional information about the LiDAR measurements. But here are some preliminary technical takeaways from our NHERI report. So first conclusion is local conditions drive variability. So storm surge and waves caused major impacts that differ strongly by sites. Then scour was a key damage factor. So erosion frequently destabilized earthen and hardened structures. Then, of course, flow matters. So flow blocking structures were hit hardest, and partial flow through improved in general the performance. Elevation is critical, so extreme surge exceeded the height of some elevated structures. Then sediment type influences stability, so erodible sediments can undermine infrastructure support. And barrier island breaches are highly dynamic, so their rapid evolution, especially under storm sequences, is hard to predict. And some general takeaways from our NHERI report and our reconnaissance efforts are that interdisciplinary data is essential. I hope you get the idea of what I presented. So capturing hurricane impacts requires methods that span multiple disciplines and processes. And of course, timing matters. So pre, during, and post-storm data together create a complete picture of how conditions evolve. But it is very challenging to really get at the right time to the right spot, yeah, so that you deploy the sensors at the right location. Yeah? So then broad relevance. The data set supports work on coastal processes, surge wave structure interaction, soil water dynamics, and sediment instability. And there's a strong value for applications. So it provides a foundation for case studies and for calibrating and validating numerical models. So each method gives us a part of the picture, and together they create a rare data set that can help us as engineers, modelers, and decision makers. But we also want to know from the end users what they really need, yeah, to get a feedback. What type of data do they really use? So do they use data from the air, the soil, water, land? What are they interested in to make decisions, for instance, or to bring it into their models? And as well, we want to know for which point in time they need it. So before, during, or after storm, do they need the whole picture? Are they just focusing on before and after? Or this feedback is really important so we can improve future fieldwork and plan our deployments better. So you can see here, we just added this question mark in red. We only recently received funding for a longitudinal study with an NSF EGA. So those two breaches will get now regular monitoring spots to get long-term data sets for calibration and validation of numerical models. And breaches formed by the same storm may evolve differently due to sediment properties, vegetation, or human activities. And I hope you were able to see that they already evolved in a different way. Yeah. So the EGA is called Collaborative Research, Longitudinal Investigation of 2 hurricane-generated barrier island breaches in Southwest Florida. And the project will end in September 2027. And here below, you can see the aerial imagery for before and after the hurricanes, where you can see where the breaches appeared. So here a short project overview. It investigates the development of those 2 barrier island breaches and focuses on hydrodynamics, sediment properties, geomorphology, and vegetation. It addresses knowledge gaps through multi-season, multi-year monitoring, and it aims to improve coastal management, planning, and engineering design. And the data will support calibration and validation of models. And it will enhance interdisciplinary natural hazard research networks, hopefully. So here you can see a few of my team members, but there are a lot more involved. So here, for instance, you can also see Michael Bennett, who's part of the here of today's meeting in action. And yeah, there are a lot of more people involved that are not included on those pictures, but their work made all of this possible. And I can tell you, Florida is beautiful, but collecting data and hammering the whole day or carrying heavy equipment around in summer heat is not a joke. Yeah, so I really appreciate the efforts everyone put in. So thanks again to all team members and institutions involved. The NHERI report written by our team and led by Nina Stark and Mike Gardner will be published soon, likely in spring next year. And the results show today are preliminary. So they highlight what data products are available and share our first observations. So we encourage everyone to explore our data sets further for research and educational use. At the end, I would also like to invite you to join us during ICCE in Galveston, Texas. That's the International Conference on Coastal Engineering. So there we will organize an international workshop on optimizing post-hurricane reconnaissance on Sunday, May 17th from 12 to 5 p.m. You can sign up when you click on program, and there's a form. Unfortunately, we have only 50 seats available, but we try to get as many people in as possible. And because this year is the Graduate Student Council, I would also like to advertise our Young Professionals event that I'm co-organizing because I'm part of the Coastal Engineering Research Council from the American Society of Civil Engineers, and they are the representative for young professionals. And I'm organizing our first Coastal Engineering Research Council Young Professionals meeting to bring all young professionals from internationally together. And then we will have also a networking event after that and social event. So please join us if you will be in Galveston, Texas. So those are my references. And with that, I would like to thank you for your attention. And I hope you were able to see that I'm really passionate about this topic, because I believe it can help protect people from future events like these. That's why I initiated the international workshop during ICCE. And going forward, I want to help make these data collections more efficient by identifying the minimum equipment we really need and the types of data that are most useful for the stakeholders who rely on them. So feel free to reach out to me via email or even better via LinkedIn. Thank you very much.
Thank you very much, Dr. Schueller. Yeah. It was a great presentation. So we have few minutes for questions. So if you have any question, you can ask Dr. Schueller now.
I have a question. Um, Actually, I have two questions. First, thanks for the presentation. It is very nice, and I went through though some of the things I didn't understand, considering I'm like social scientist, not civil engineer. But the question for me to you, like you collected the data of Hurricane Helene and Milton, and as personally I work on Hurricane Helene and Milton project for my PhD dissertation. So the question is like, you have those geospatial data or geocoded locations that house has been damaged, and from that, can you identify like how much debris, like hurricane debris, will be generated after like identifying those heights and those damage types? I know like you are trying to figure out like damage types, what 1 to 3, but yeah, 1 to 3 scale, because I know like FEMA did that with their photo survey and everything, but that's not exactly accurate. So do you have any kind of thoughts on that, considering while I was talking to state local government officials after Hurricane Helene and Milton, like I was doing an in-depth interview, what are the challenges on hurricane debris management? So they talked more about like if we had access to how much debris will be generated from each area, that would have been helped. So do you have like those data, and do you have those geocoded location in the uh, database?
About your question with the structural damage and the categories. So for Horseshoe Beach, for instance, the STIA, the other EER, with the structural engineers, they were on site as well and collected data. And I think they structured it into those categories. So those EERs work in a completely different way. So I know that the EER, the STIA data collection is much more standardized. So they have their protocols that they follow all the time to categorize the structures. And GEA and NEER need to, I would say, need to be a little bit more sensitive about what is going on site, and then they figure out which methods they use finally after a pre-assessment. And your question about debris is that I would say you can see it in the LiDAR, yeah, but that is all that we did. You can see it in the LiDAR and in the aerial imagery. So you would need to analyze the data further. So we haven't done this. So we just collected the data, but this would be something for the end users to work on it.
Yeah, thank you so much. I was like, I know remote sensing and LiDAR, but the problem with how much debris will be generated by building, because there are like so much household applicants also there in that building. So that's like a challenge to quantify based on that building size. Also, things are into the home. So definitely, thank you.
You're welcome.
Any more questions?
Sorry, just one more question again to follow up. So I'll get the data. For me, I was now current now, I'm like looking into the geocoded data. So from STEAD, is it possible to get those geocoded data, or it's still the imagery or LiDAR data?
You mean the data that we collected?
Yes.
If it's you want to know if it's georeferenced? So yes, and it was collected by the Rapid facility. So this is high quality data that you can get on our Design Safe project. When you click on it, everything is sorted by site. I think you will be interested in the Horseshoe Beach area, I guess. So you can click in
And
and then
Sarasota. And Sarasota. Yeah.
Sarasota. Okay, we haven't collected data in Sarasota. So Sarasota area focused on those breaches. So we have no structural data about buildings for this area, but we have data about structures and buildings for Horseshoe Beach and Cedar Key area.
Okay,
Yeah.
cool. Thank you.
You're welcome.
Yeah, our time is up. But if you have any question, you can contact Dr. Schueller directly. Again, thank you so much. It was a very great presentation for the great project. And thank you all for attending this presentation. I hope you all have a good day. Thank you.